In Eulerian description, as I said, we consider a certain mass or volume of fluid and then we study the motion that takes place with respect to that fluid. So here is a control volume shown in the dotted line, and let's say the fluid properties that we need to be able to study the motion of the fluid will be the coordinates of a certain point x, y, z, the velocity associated with that represented by the velocity vector, and it depends on x, y, z and the time t if it is time dependent, if the motion is not steady, and similarly the pressure that is associated with that. You may note, and you may already know, pressure is a scalar quantity while the velocity or acceleration, they are vector quantities. So in Eulerian description, we don't really care what happens to individual particles. We are not bothered, and in fact we just take the important parameters like pressure, velocity, acceleration and so on, whichever is of interest to us for a system, for a fluid volume that is under consideration. At many occasions in the Lagrangian description is of course useful, but Eulerian description is more convenient for fluid mechanics applications, as we will also see as we go along. And in Eulerian descriptions, we define field variables like pressure, field and the velocity field at any location and at a certain instant in time. So we just take any volume that is under consideration, take a point and choose its coordinates x, y, for example, if we are considering only two-dimensional motion and so on, and then related to that we calculate the velocity and so on, and then generate equations of motion from there.